Welcome back to the morning show. We're talking electricity today with the wise guy.
Good morning.
Good morning, Matt. How are
you were
you?
going to say something.
No,
Something like Matt Sellen, University of Illinois physics professor, is here, and he's going to light things up for us.
I couldn't wait to get to the demonstration.
I know.
Well, we're going to explain why a bird doesn't get electrocuted and why sometimes a squirrel, does. And we're going to actually have a little fake squirrel that we're going to experiment with in the second part.
If the lights happen to go out in the studio at the same time, we're
But the first thing we have to do is explain why electricity flows in the first place, which has to do with something called a circuit. But let me first say, because yesterday was Veterans Day, I'm wearing my flag shirt.
Very patriotic.
I really like this shirt. Okay, so it's very important when, if we're going to make electricity flow, that it has some place that it starts and that it has to go all the way around and end up in the same place afterwards. It's called a circuit. And a circuit just means that you basically end up where you begin. So like if you do a circuit in a track and field event or something, you run around the track and things like that. So if you just have a battery, and you can do this experiment at home, this is the only one we're going to do today that you can do at home.
Okay.
Okay? If you take a battery and you just have a little light bulb like this, and you hook up one side to, let's say, the positive side of the battery, nothing happens.
Right.
Okay, and this is kind of a hint. This is sort of like the birdie that's sitting on the high tension wire. If you're just sitting on one wire, the electricity might try to go into you, but since it has no place to go, it doesn't really go very far. It just sort of stops, and so it doesn't hurt you. If your other foot happens to touch the other wire, then you light up.
Bingo.
Okay. So what we have here is a complete circuit. We have electricity flowing from the positive side through this little light bulb, which is just a wire that gets very hot, down to the negative side. So that's a key ingredient. You have to have someplace both for the current to start and for the current to end up.
And it doesn't make any difference if it's alternating current, AC or DC?
No, the same.
Everybody's got to have a circuit.
Everybody's got to have a circuit, whether it's alternating a direct current, and if I switch these legs around, the current will flow the other way through the bulb. The bulb doesn't care. It just gets hot anyway.
Right.
It's just getting warm. Okay. So now we can explain what happens in your house. So I have here a very old demonstration. You can tell it's old for a couple of reasons. First of all, it's an old wooden frame that's been screwed onto a blackboard. And then you have exposed copper switches with 110 volts on them, which you can never get away with today. So I'm going to plug this in. So, Robert, don't touch it.
So you're putting us in violation of all kinds of codes right now, right?
I'm sure I am.
Right.
But we're only on for a short while, so it's okay. Now, there's two ways that you tend to wire up electrical circuits around your house. In fact, around your house, it's mostly commonly the parallel way. So what you see here is a switch. When I throw the switch over this way, what I'm doing is I'm taking the current or the voltage that comes in from the wall socket, and I'm just applying it to these two light bulbs over here. And it's wired up so that on one side of both light bulbs, it's always the same voltage, and on the other side, it's always the other voltage.
Right.
So the current flows from the top down to the bottom through both of these bulbs, and this is very useful because when one of your bulbs blows, it doesn't stop the other one because the current still just flows through that one. Okay. And you'll notice those are pretty bright, too.
Right.
Now, the way some Christmas tree lights are wired up is called in series, and what you do there is you have the current flowing through one, then through the other, and then back again to the source. And this is like a daisy chain. And so two things you'll notice. First of all, these are kind of dimmer. That's because they're sharing the voltage. So half the voltage goes across the first one, basically, 60 volts across the first one, 60 volts across the second one. And what's even worse, if I disconnect one,
your whole string of Christmas lights goes out.
Right.
There you go.
Because now there's no current flowing through here. It's like an open switch, and everything goes out. And people may have, you mess around with your Christmas tree, and you futz, and then you throw it away and buy a new string.
Exactly.
Every year you buy new
That's
ones.
why they're cheap.
So this is called a series circuit, and the other one was parallel circuit. Okay.
Well, we'll explain how this applies to
So next
squirrels.
time, yes, we'll have a very unfortunate
and electricity. That's all coming up on the morning show. Stay with us.